Okay, hello everyone. Welcome to this UK Data Service workshop on using QGIS to map 2021-22 census data from the UK Data Service. Your presenter today is James Crone, and we also have Nadia Kenner who will be helping to answer your questions.
Thanks, Jill. Welcome to this webinar. We're going to use QGIS to map 2021-22 census data from the UK Data Service. So the aim for the session today is really to use the QGIS desktop GIS application to map 2021 and 22 census data from the UK Data Service. I'm going to create a univariate chlorophyll map, a bivariate chlorophyll map, and an area cartogram using QGIS. And along the way, we're going to learn various parts of using census data and using QGIS. So you will learn how to download 2021 census aggregate data and 2021 census boundary data from the UK Data Service using our various tools that we create. And you will learn how to carry out various data transformations and data processing on the downloaded census aggregate data that you downloaded from the UK Data Service to prepare it for mapping in QGIS. And then we'll also learn about some of the issues we need to be aware of when mapping census data. Specifically, we're using QGIS. So if you've not used QGIS before, you'll get an introduction to QGIS, and you'll see how QGIS can be used to create maps and other types of geographic visualization from census data. And then I'll do a bit of highlighting of some of the resources within the UK Data Service that can help you using census data and mapping census data. So the format for the webinar will be a series of presentations. They'll be quite short, just to introduce some theoretical stuff. And then I will dive into doing some actual practical stuff, which could be downloading stuff from UK Data Service, some data manipulation in Excel or LibreOffice Calc, or stuff in QGIS. And then I'll do back to the slides, throw some theory stuff, and then go back to the practical stuff. So it'll be sort of flipping between doing slides and doing actual practical stuff. Because the idea is to make sure you understand how to manipulate the actual data from the UK Data Service in QGIS to produce an actual outcome. And you should have been emailed a set of joining instructions, which should have pointed to our UK Data Service GitHub, where we've put all the materials for this webinar. So that's the slides and this workbook. And the workbook will form the basis of everything I'm going to be demonstrating today. So you may already have looked at the workbook or tried some things out already, in which case you'll get to see me doing them, or later you might just work for the workbook yourself, having seen me do it. And there's also some backup data sets there. And this shouldn't be a problem, but just in case there's any problems with the actual server today and we're not able to download our data, then we've got the backups in the repo. So if you've not already done so, then perhaps afterwards you can go and download the PDF workbook, etc., from our GitHub repo. So a bit of introduction about the census itself. So the census in the UK is carried out every 10 years. Within the UK Data Service Census Support, we specifically support the census from 1971 onwards. So 71, 81, 91, 2001, 2011, 2021 and 2022. The reason for 2022 is because in Scotland the census was delayed by 1 year. So rather than having it in 2021, which happened in England and Wales, it happened in 2022 because of the effects of the COVID pandemic. Scotland decided to delay it by a year. So the census is essentially a big population survey. Traditionally, it was carried out by sending out a paper form. It tends to nowadays just be filled out online. But I mean, you can see the sort of questions that are asked in the census. So there's a mix of household questions and questions about individuals. So the household questions will be stuff about what sort of accommodation do people live in? So is it a flat? Is it a house? How many rooms are in that building? That flat rather. Types of central heating. So does it have no central heating? Electric central heating? Information on tenure. So do the people in the house rent? Do they have a mortgage? Are they a social renter, or do they rent from a private landlord? And then the individual questions are about that individual themselves. So it could be things about their age, obviously, their sex, and questions like how do they travel to work? So what mode of transport do they use to travel to work? Do they walk? Do they take the bike? And then how far do they travel to work? Mhm. And so all this, the on the census night, which is usually a night that people will fill in and submit the census form. This gets sent to the national census agencies, which in England and Wales is the Office for National Statistics. In Scotland, it's the National Register of Scotland, and in Ireland, it's NISRA. And the census agencies collate all the census data. Sorry, and so this is just more information on sort of questions you get asked in the census and the sort of data that will be produced by the census agencies. So education, you could get back information on the number of school children or the number of students, the highest level of qualification. Transport, again, is that stuff about how do people travel to work or home and the sort of distance they traveled. And housing is a sort of accommodation type. So again, are they living in flats, houses, or semi-detached or terraces? And so the census agency can pile all the data and they produce this thing called census aggregate data, which could be is information on counts of people or households by these small areas. So it's essentially counts of people or households by these small areas. And within the UK census, the smallest area geography for which census data is produced is called the output area. Yeah, so census data gets output by different small areas. The smallest of which is output area here. And you can see the output area. This is showing a bit of Edinburgh. So each of these like regions is an output area. So it covers like a street. And then you just get the different types of the data. And there's two types of census data. There's univariate census data, aggregate data, and there's multivariate aggregate census data. So the univariate data is just information about a single census variable, whereas the multivariate is much richer and it combines different census variables and gives you the ability to look at the relationship between those variables. So an example of univariate data could just be method used to travel to work. The multivariate would expand that further by adding extra dimensions. So it would be method used to travel to work broken down by age or occupation. And that would then allow you to look at how do the elderly versus children or people of working age travel to work, rather than just saying, just have that general, how do they travel to work? It just allows you to look at the relationship and do a sort of extra dimensions of insight into the data. And so the UK Data Service, which is the UK's largest collection of economic, population, and social research data for teaching, learning, and public benefit. And the point of the UK Data Service is to provide access to the data and training about using that data. And so the UK Data Service covers a lot of different types of data, one of which is census data. And so within the UK Data Service is a specific team called UK Data Service Census Support. And we specifically provide support to the census. And we're spread over different institutions. So, for example, I'm based in Edina at Edinburgh University. The folk and I look after the boundary data and the census geography data. The team at GISC who look after the census aggregate data itself. And then we have a team at University College London who look after the census flow data. That's migration data. So we have census aggregate data, census microdata, census flow data, and census boundary data. And today we're going to look at the census aggregate data and the census boundary data. I'm not going to cover the census microdata or the census flow data, but my understanding is there's going to be webinars coming in the future where the guys from UCL will talk about the census flow data, and they'll probably be talking about the census microdata as well. So the census microdata is looked after by the folks at the Cathy March Institute, which is also at Manchester. So in terms of the census aggregate data, to access the 2021 and 2022 data, there are two applications. There's CCAN, which provides bulk access to the census aggregate data, but no ability to filter or extract subsets. So the CCAN gives you the access to the raw large census tables. So you could download stuff on, I don't know, accommodation type, but you could only get the data for all of the UK at the various small output areas or by ward or lower super output area. Whereas Data Explorer gives you much finer granular detail to the access to that data. So you can subset and only extract data at ward level for Leeds or Manchester or York. And there are some legacy applications within the UK Data Service Census Report called Infuse, which provides access to 2011 data and 2001 data. And these are in the process of being ported to Data Explorer. So that Data Explorer will become the sole mean or the primary means of accessing census data within the UK Data Service. And so we're going to have our first demo where I'm going to use Data Explorer to download 2021 census aggregate data for Leeds at ward level on accommodation type. And this same data set we're going to use throughout the webinar today to do mapping in QGIS, and we're going to look at how the data manipulation to do that to the census data as it's provided. So I'm just going to stop my slides here. And I'm going to open a web browser and go to Data Explorer. So let's go to the UK data. Let's make this full screen. So it's the UK Data Service website. It's the UK Service Data Catalog, which allows you to search through all the data holdings held by the UK Data Service. And we have this link down at the bottom here for census. And this provides a link to all our census support applications, which provide access to census data. And so we've got Data Explorer here, and Infuse, which is a legacy option, and CCAN is that bulk data platform. And then we've got three here called postcode directed download, postcode data selector, and bound borders. And these provide access to the boundary data and geographical lookup tables. And Wicked, which is the access to flow data. And we've got some historical census data here. But I'm going to go to Data Explorer because we want to get some 2021 census data. And so this is Data Explorer. And along the bottom, there are some drop downs where we can access different types of data. So currently it's got the 71 census data and a 22, 21, 22 census data. And also has access to other types of non-census data. So stuff from the World Bank and International Monetary Fund. But I'm going to access the 2021 census data. And I'm going to get data on accommodation type. So I'm going to follow through my PDF workbook and see what we want. So we want 2021 census accommodation type. So Data Explorer, this is the data set we're going to download. And this is a univariate census data on accommodation type. So it's down the left here. So it selected this data set. And down the left here, there are various filters we can apply to that data set to constrain what data we want to extract from it. At the minute, it's pre-selected census year because it's a 2021 data set. I'm going to first pre-constrain it to England. So by using the top level geography filter. So we select England, click apply. And so it's applied a top level geography filter of England. On geographic grouping, I now have to choose the level of output geography that I want to select the data for. So in my case, I'm going to download by ward. And I'm not going to do the survey now. I'm going to download data for ward, specifically metropolitan electoral wards for Leeds. Because in Leeds, it falls within metropolitan districts, which fall in metropolitan counties. So I'm going to grab electoral wards. So again, select the type of geography, click apply to apply the filter. And now I need to pick where in the country to download data for, to subset the data. By default, it will basically show you geographies for the entire country. So it's kind of unwieldy. So what I find best to do here is to collapse all And then you can sort of manually expand the geography hierarchy, which I'm doing here. So I need data for Leeds. So, and Leeds is in West Yorkshire here. So we expand that. And so each of these items here is an individual electoral ward. And I want to select all of them. There's about 33 of them. Now I could just select them individually by clicking on the checkbox next to each one. But a better option is to use the Data Explorer change selection mode option, which will tell Data Explorer to select things in a different way. So rather than single item, I'm going to go to item and all items directly below. And that means I can just select on Leeds, and it will select all the items below Leeds. So that's going to be all the electoral wards within Leeds. Again, so they're selected. I'm going to apply that selection. So it's selected 34 electoral wards. And finally, I need to tell it what the actual data to select, so the census variables. And again, we want accommodation type. And I'm going to take all, so detached, semi-detached, terraced, caravan, whatever. And again, I'm going to change selection mode from single item to all items direct below. So do that, click apply, and you can see we've now got another filter added. At this stage, within Data Explorer, I can preview the data. So here's my data previewed. So down the left, we've got the different wards. It's currently just showing the ward name. And then the other columns are the different variables. So detached, etc., part of converter, shared house, etc., including bed sits. So that's me. I'm happy with that. And now to download the data from Data Explorer, and to use that, I use the download button. It's got different options. We can download in Excel, filter data or unfiltered data. The Excel will just download like a view of this with the same formatting, but it can be hard to manipulate later on in, say, Excel or LibreOffice. Don't pick the unfiltered data, because that will literally return the entire data set. So rather than a nice subset of data just for Leeds, it will return data for the entire England and Wales, which is a lot of real records. So the one we want is the filtered data in tabular text. And so let's grab that. One of the quirks of Data Explorer is that the download file has a massive file name, which is extremely unwieldy. As you can see, it's basically construct a file name from like the data set and then the level of geography, and each of these represents an actual record in the table. So I'm going to rename the file to something a lot more usable. I'm just consulting my guide to see what I've renamed this as. So accommodation type. So rename that. So that's a lot more nicer name. Can give you a quick look at what the data set looks like. I'm on Linux, so I'm using LibreOffice. And I'll be demonstrating all my data manipulation in LibreOffice. The workbook includes instructions in both LibreOffice and Excel if you happen to use Excel. So this is the sort of data we get. I'm going to go back to slides now. So we've got our data from Data Explorer. Before we can map this data, we need to do some manipulation of it. So the data from Data Explorer is provided in, it has a long shape. To use it in QGIS, we need to convert it from long to wide form. I'll explain what that means in the next slide. We need to normalize our census variables. At the minute, they're just raw counts of people or households. We want to make them proportion to the total population. And I'm going to add an extra summary variable to that data to make it, to create a sort of categorical map later on. And I say the census aggregate data is tabular data, So it's a big CSV file. And a natural place to manipulate tabular data is in a spreadsheet application like LibreOffice Calc or Excel. I'm going to use LibreOffice Calc because I got Linux. So I say the census data from Data Explorer becomes in a long form. So what do I actually mean by that? Well, the way a tabular data set is organized into rows or columns is known as that dataset shape. And a dataset shape may be long or wide. So you can see that here. So this first example here shows data in long form. And in long form, the data is spread over multiple, for the same geographic instance, it's spread over multiple records. So let me just get rid of this. So here we've got 3 electoral wards. So these are geographic identifiers. So E05011384, E0500183885, and E05011387 are 3 electoral wards. And the accommodation types, the different census variables, and the observation value is the actual count of the properties or people of that particular type. And so the data is spread over multiple rows. And that's long form. In wide form, again, we have the same 3 electoral wards, but this time all the different variables, the different house types are contained on a single record for each of those electoral wards. And they're just properties of a single row. And there are pros and cons of these, but for our purposes, the data from Data Explorer comes in because it comes in long form. In order to be able to map it in QGIS, it needs to be in wide form. So we have to do some data conversion from long to wide form. And the process of doing that data conversion within like a spreadsheet application like LibreOffice Calc or Excel is to use a pivot table, which will essentially aggregate the data via the unique geographic identifier and then do the transformation to long to wide form. If you were in if you had the data in a relational database, then you could write SQL to do something differently. Or if you're using Python or R and you're using pandas or something, you could do different transformations that way. But for our purpose, in LibreOffice Calc or Excel, we will create a pivot table. And that will do that conversion to long to wide form, enabling us to map the data later in QGIS. And then we have to normalize the actual census variables themselves. So when we download the census data, it becomes as raw counts as people or households. And we shouldn't just map those straight away because they simply tell you. So if you had like the raw counts of people in detached houses or terraced houses, those numbers will just be big with as lots of people as lots of households. They don't actually they don't give an indication of why they're big, which is why we have to normalize them so that we can compare them to other areas. And then to normalize data, there are 2 means you can do that. You can divide it by the total geographic area, so you can express that variable as density, so the number of terraced houses per kilometre square, or you can express it as a total of the population size, so as a percentage. So this is actually showing tenure data rather than property type. But you can see the total here is, in this particular ward, is about 9,500 people or households. Mortgage is about 4,000, so 4,000 divided by 9,000 gives us about 40%. So you can say that 40% of people in that ward live in households that are mortgaged. And then to the data, I'm going to add an additional variable. So we've got like for house type, or in this case tenure, we've got 8 different variables. And what it's quite useful to be able to do is to show what is the dominant variable. So what is the most, in that ward, in what type of tenure do most people live in? So I've created a new value called dominant tenure type, which looks across all the columns and will tell you in that ward what is the dominant tenure type. And that's quite a useful summarization of the 8 variables. And so in the next demo, I'm now going to take that census data from Data Explorer. I'm going to do that transformation from long to wide form in the pivot table. I'm going to normalize the census variables, and then I'm going to add that categorical summary variable. So let's just grab the data. I'm going to move this widget again. So this is our data. I'm just going to open that to LibreOffice. So the data from Data Explorer comes with a lot of columns. There's a lot of metadata here. So it's told us stuff like the top level geography of England. Really, the only columns we actually care about are this geographic area one, which tells us the actual ward code of each of our wards, the accommodation type category, so the type of accommodation is living in, and this obs value, which is the actual raw number, which is the thing we're going to want to map. So I'm going to do the first, the transformation from long to wide form, and I want to create a pivot table. So in LibreOffice, we do insert pivot table, and we select our selection, which is the data. And then we get this like form where we have to describe how to do the pivot. And if you're using Excel, this will be slightly different, but it's the same principles. So row fields is the thing I'm going to aggregate by, which in our case is the electoral ward. So data fields is the accommodation type. And the data fields is actual values themselves. That's always a value. So that's how I'm going to do the pivot. And as you can see, that's what it's done. It's aggregated our data by the electoral ward. And it's also done it's summed it across so we get a total result. So I'm going to grab this data and do some further manipulation of it. So what I'm going to do here, I'm just going to rename these columns because they're quite long. So geographic area, this is the ward. So ward. So caravans, detached properties. Flats. Shared buildings. Shared. Schools, church, warehouses. School, church, warehouse. Semi-detached. Terraces, just about okay. So and just add a total. Yep. So let's rename the actual raw values. I'm now going to add some extra, another 8 columns for the proportional values, which will normalize each of the raw values by the total for that ward. So And I'll just add so caravan proportion, detached proportion. So let's calculate the proportion of caravans within this ward by the total. So we have to enter an expression here, and the expression is cell B2 divided by cell J2 times 100. So divided by, yep. And I'm going to reuse that expression across the different columns. So I'm going to put a dollar here to anchor the column value. Oops. Okay. And I'll now just use that across the other columns and just check. So I2, yep, terrace divided by J2, correct. Okay. So we've got a proportion of caravan, detached, flat, etc., terrace by the total population for that ward. I'll just fill in your records. So we've pivoted our data, we've normalized the data. The final thing with that is that categorical column, which just summarizes the data across the different types of census variable. And so I'm going to add a new column called the dominant accommodation type. So dominant, you see, type. And I'm going to use a different expression here, which is in the note, is in the workbook. So oops. Sorry about this, guys. Just try and grab it from actual workbook. For a moment. Okay, I clearly can't type, so that is correct. So stop it. So as you can see, it's looked across the columns and it's found the value with the largest proportion, which in this case is semi-detached. And then I'm just going to modify the expression so it strips off the dash prop from the end and we just end up with semi-detached or flat or detached, etc. So I can use a substitute. So we're going to replace. Yep. So that stripped that off. And again, because I want to use it across different records, I'm going to add some dollar symbols to lock the values, lock the references rather. So dollar here, not pound. And I'll just apply it to our own records. Okay, so now for each record, for each ward, we have a indication of what the dominant type of accommodation type is. In this case, whether that be semi-detached, terraced, or flat. And so we've done all our manipulation in Excel. I'm just going to save the data as is. So, and this will just save our single worksheet, which is good. And just close and go back to my downloaded data and do a quick check to make sure it's okay. Perfect. Yep. So we've done our manipulation of the data in Excel, ready to map in QGIS. So I will jump back to the slides again. So back to the slideshow. And so we've got the actual aggregate census data, and now we want to look at the actual boundary data, because in order to map data, we need some geographies and some geospatial data that we can actually use in the QGIS desktop application. So a bit of background about geospatial data. So geospatial data is used to model some aspects of the world. That could be the natural world, the human world, or the built environment. Within geospatial data, there's vector data and there's raster data. So vector data is collections of points, so X's and Y's, points, lines, and polygons. Raster data is gridded data. If you're familiar with photography, you get like a raster image, like a TIFF, which has a RGB value. In geospatial raster data, it's normal. It could be like an elevation value, so height, or uh, it could be a band from a satellite image. It can be used in some cases to get a population surface. So the individual square within the raster data could be a population density or a population. Geospatial data is located on some point in the Earth's surface. So we have a thing called spatial reference systems. So an example of a globe spatial reference system is WGS 84, which is Latin long, and that allows you to reference spatial data on the globe. The British National Grid is a different type of spatial reference system, and that's used in the UK, typically to map Ordnance Survey data or data from the Office of National Statistics. You can have spatial relationships between different types of geospatial features. So you could have a point, and you could do operation to say, is this point within a polygon? Is it within a distance of a line, and the line could be a river or a road? You get a whole variety of types of data format in the geospatial world. We'll see some today when we download the boundary data as a thing called an Esri shapefile. You also get a thing called a geopackage. If you've used Google Earth in the past, it had a thing called KML. There's a bunch of different geospatial standards we don't have time to go into here, as well as geospatial data and geospatial system science. There's a specific type of software application called a GIS application, so a geographical information system application, which allows you to manipulate geospatial data, to manage that geospatial data, to create geospatial data, and do processing of that geospatial data, and to create maps. So within the GIS world, there's a company called Esri, produce a proprietary set of GIS software called ArcGIS, which you have to pay a license fee for to use. Although if you're in a university, there are normally some educational licenses to access ArcGIS. However, within the world of GIS, there's a thing called QGIS. The Q originally stands for Quantum GIS, and it's an open source desktop GIS application, which is free to use and has become really quite powerful, with almost as good as functionality as ArcGIS. And because it's open source, it gets a lot of contributions from the community. And QGIS is the thing we're going to use today. I use QGIS for all my work at Adina. It's also used by a lot of folk in the UK education system because QGIS is really quite nice. So before we look at QGIS, a quick note about the census output geographies. So we saw earlier the mention of the output areas, and we down to the data by a literal ward level. So the census area data is output for a range of different small area geographies. And together, these census output geographies form a output area geography hierarchy. So from the smallest output area up to, say, ward or local authority and then the country. But because of this thing called statistics disclosure control, not all the census variables are available at all levels of geography because they have to try and protect individuals. And you could make that you could buy if you had like a small area that only had a few people in it, you could possibly reveal individual data, which would be bad. So say not all census variables are available at all levels of geography, and some may be only available at the higher areas, so by ward or district level rather than at output area level. Census boundary data is a geospatial data set that provides the actual shape and location of those small area census output geographies. So on the left here, we have some council area boundaries. This is for Glasgow. On the right, some output area boundaries for a part of Glasgow. And again, you can see the difference in size between the council area boundaries and the output area boundaries. And we have a thing called a geographic lookup table, which encapsulates the relationship between two or more types of geography. And this enables you to do georeferencing and also geospatial data linkage. It would allow you to convert, say, from output areas. If you had data at output area, you could use a geographic lookup table to go from output area to ward to local authority to country. A special type of geographic lookup table is a postcode geography lookup table, which contains information about all the postcodes in the UK. So where that postcode is located in terms of X and Y within the British National Grid coordinate system, and lookups to various types of geography, which could include census geographies. So you might have a postcode, so EH10 4XF in Edinburgh, which has a census output area column, And that census output area column would have a 9-digit code. And then you could then use that code to attach census data to the postcode and then look at how census variables varied by postcode, which can be useful if you have other data that's at postcode level, like survey data, like if you've done like a consumer survey of like, I don't know, people's recycling habits or things they'd bought. So that's a great way of tying data between different types of data. And so then the UK Data Service, specifically census boundary data, we provide the actual geographies of the census. And we have 4 different applications. We have easy download, boundary data selector, postcode directory download, and postcode data selector. I'm going to look at boundary data selector, and I'm going to download boundaries for leads so we can map to our actual census aggregate data. So I'm going to use boundary data selector to download electoral wards for leads. So I'll just close some of these windows. Back to the UK Data Service, back to the data catalog, back to our lovely pop-up, and onto census boundary data. So this is the boundary data selector. Essentially, it's quite a simple application. So there's a selection of filters on top of our database that allow you to look for different types of boundary. So you've got a country drop-down, a geography drop-down, and a DATS drop-down. And I want to get data for England electoral wards. So England electoral boundaries 2021 and later. Electoral wards 2022. Again, like in Data Explorer, I can now drill down through the geography to get a subset of data. So again, Yorkshire and the Humber. And I want leads. And again, there's some control over what sort of output format we get. These are different types of geospatial data set. I'm just going to go for the default of shapefile. Do a data extraction. And so boundary data selector has come back quite quickly with our data, which I will just download. Extract that data, and it's a shapefile. So a shapefile consists of 4 individual files, and you need all 4 to be able to actually use that data, because the shape will hold the actual geometries, and the DBF will hold the attributes, and there's like a PRJ file, which tells it indicates what spatial reference system that data is provided in. And if you have any of these missing, then you're going to have problems when you try and open it in QGIS. So always keep your different components of the shapefile together. This is one of the benefits of other formats like data geodate packages. It keeps all the data in a single file, and there's less chance for stuff to go wrong. But the Esri shapefile is almost like a de facto standard in the geospatial world, much as the CSV file is a de facto standard in the other data world. Oops. And then when I do the mapping of data in QGIS, oops. I'm going to use some contextual background mapping from the Ordnance Survey, just to give some context to the census data. So this is data not from the UK Data Service, but from the Ordnance Survey, who are Britain's national mapping agency, and they provide data, both commercial data and open access data. So I'm going to do a search for the Ordnance Survey. And they have a data hub where they provide all their data. So this is the Ordnance Survey Data Hub. and you can go to data, and you're going to go to open data. And it currently is listing 27 types of data, but we can filter what we want to see, and we just want to see background mapping. So maps the imagery and changes to ordnance survey. And so the data set we want is this 1 to 250,000 scale color raster, because it provides like nice background mapping. It's like a road atlas almost. But for our boundaries, it's great. So I'm just going to grab that. It's relatively big. It's 134 megabytes. That's the ordnance survey data. It comes with like documentation that tells you what the data. It comes with like a gazetteer and sort of a README that tells you how the data is licensed. That's the actual data itself. So it provides the maps basically be broken into lots of little, these are like 100-kilometer square blocks of map data for the whole of the UK. They're into small bits so that the overall file doesn't get too big. And when we come in a bit to QGIS, we're going to add one of these squares of data just for leads to give us some background information. So in this next section, I'm going to now add all our various data sets to QGIS and just give you a quick introduction to QGIS. And now we can get on with actually mapping the data. So, so, so let me just start QGIS. I'm using QGIS version 3.44. If you read our joining instructions, there was a comment there about don't use the latest version of QGIS, which is QGIS 4. QGIS 4 has just been released. And it's likely, it's quite, because it's like this is a free version, and sorry, so it's a 3.44 version, and the version 4, the going from 3 to 4, it's likely to be quite different. So the advice at this time of using our workbook is to stick to the 3.449 version, which is what they call a long-term release. By long-term release, they mean it's unlikely to change the features of it and how it looks and stuff. Whereas a 4 version could be quite different. So the current advice is to stick to the 3.44 version. So by default, in the way I got QGIS set up, I've got the projection set to a lat long, so WGS 84. But because all our data, the census boundary data and the ordnance survey data is from the British National Grid, I'm going to first tell QGIS to use the British National Grid rather than WGS 84 to show the data. And in QGIS, the way you do that is by clicking in the spatial reference thing in the bottom corner. So at the minute, I set to WGS 84, and you can see it's a world one. I want to set to the British National Grid. I just apply that. And you can see that this EPSG 27700 is just a code that is used to describe British National Grid. It was 4326 before, and again, 4326 is just the code for WGS 84. And in QGIS, to add data, what you use is this button here, which is called the Data Source Manager. And you click the Open Data Source Manager. Down the left here are the different types of data sets that QGIS can read. So the ones we're going to use today are vector, which would be open the census boundaries, raster, which would be that ordnance survey backdrop mapping, and delimited text, which will be the census data we downloaded from Data Explorer and we manipulated in Excel. For now, to start off, to give us some context, I'm going to add that ordnance survey data. So I go to raster data, and then browse to the data that I downloaded. Again, we've got the different squares of data here. I'm going to find the right square for leads. I'm just going to check my workbook to make sure I add the right square. That's I'm scrolling through it now. That's se.tif. So, and you'll see, just maximize this. You'll see by default, QGIS has drawn the raster image, but the quality is not great. Basically, we can improve that by QGIS has prioritized the draw performance rather than the actual quality. So we can improve that by sacrificing draw performance by making QGIS display this map a lot clearer. And again, so what we have here is the QGIS main map window. And then down the left here, we have the different layers of the geospatial data layers that QGIS is currently displaying. And we can so we right click on any of these layers and go to the properties, and we access various properties of that layer. Later on, we'll use this properties value to do sort of mapping of the census data. And for now, I'm going to use it to control the quality of which this raster layer is displayed. And the way we do that is to change this resampling here. So the minute it's using this thing called nearest neighbor, which is fast, but is not particularly great for quality, I'm going to change that to cubic and do some oversampling of 10. And when I do this, there's a delay, but now the map is a lot clearer. And if we zoom in, here we have leads. So this is going to be our area of interest for today is leads. Sort of Yorkshire. So this ordnance survey backdrop mapping, as I say, it's almost like a road atlas. It provides quite small scale data, but it's great for context. It's got some stuff about the natural terrain here, sort of the moors and the rivers, lakes, and the urban footprints and stuff. The next data set I'm going to add is the census boundaries. So again, open Data Explorer, Data Source Manager. We want vector data. So into the boundary data. It's this England ward shapefile. So to add it, you click the actual shape and QGIS will pick up the other files. Add that. So here are our census boundaries. So in QGIS, this I button is the identify button. So you can just use it to basically identify features. So I've identified this polygon. I can see it's got these different attributes here. So it's got the ward code, the ward name. The ward name W means it's like the Welsh name because ONS provide data for England and Wales. Some of the Welsh data has actual Welsh local place names. So the Welsh version of the Anglicized place name. Label is the internal attribute that we use in Adina to allow boundary data sets to drill downs of the data. And name, again, is an internal value that we use in Adina. This is vector data, so I can select one of the polygons. I can select a load of polygons. I can select an individual one. I can do some quick spatial analysis. So I've got one polygon selected here. And I can run some spatial analysis here to find all the other polygons that touch this selected polygon. like this. And you can imagine if you're in a different data set, you could do the same sort of thing. So you could overlay some points or some other polygons and find out which wards were within them or within distance of them. And at the minute, because they're just census boundaries, I say there's no actual census data attached to them. It's simply the location and the extent of each of those small area ward boundaries. So the next data set, and in QGIS, you could use this button here to clear the current selection. I'm going to add the actual census data itself. So that's the data we took down from Data Explorer, manipulated in Excel to do our pivoting, normalization, and add that categorical value. And this is a delimited text. So again, just navigate to the data. That's our accommodation type. A couple of things to be aware of here. The geometry definition, because it's just a CSV value, it doesn't actually have any geometry on it. It's got a reference to geometry, but no actual geometry, so no actual polygons or anything. So we need to make sure that's set to no geometry. And we just add that. And it's not added the actual data in the map view because there's nothing to actually show. But we can open the attribute table. So at the minute, so this is QGIS has started. At the minute, it's set to use data in the WGS 84 lat long coordinate system, which is use a code of 4326. And I want it to use a British National Grid. So the first thing I'm going to do is change from WGS 84 to British National Grid. So I use this control at the bottom right here, which opened the coordinate reference system for QGIS, and you can see it's set to WGS 84. I'm going to change that to British National Grid and click apply. Okay. Put this bar over here instead. Maximize QGIS again, and you can now see it set to EPSG 27700, which is British National Grid. And I say to add data to QGIS, we use the Data Source Manager, which is this button at the top left here. If you mouse over it, it will say Open Data Source Manager. And in Data Source Manager, you can add different types of data to QGIS. So I'm going to quickly add the raster data set. So it's the Ordnance Survey stuff. So data, that's SE, I think. So yeah, that's for leads. And again, as I said before, the quality by default in QGIS is not great because QGIS by default was optimized draw speed over actual look. So I'm going to make it clearer. But all of these steps are in the handbook. So if you miss what I'm saying, you can refer to the PDF. And so it's a lot clearer because it's using a higher quality filter to display the data. And I'll just add the boundaries. So the boundary from boundary data selector, vector data, the shapefile. Yep. So here are census boundaries. It's just literally boundaries. There are no actual census variables attached to them. It just tells you where each of those electoral wards is and the extent that they cover on the ground. And then we want to add the actual census data that we grabbed from Data Explorer and that we manipulated in LibreOffice Calc. So it's delimited text. It's a combination type. And again, because the actual CSV file that we download from Data Explorer doesn't actually contain any geometry, so it doesn't contain a point or a polygon. We have to make sure that in QGIS we say no geometry. And it gives us a preview of what that data actually looks like before we add it. So you can see that looks like the data we created in LibreOffice Calc. So I can add that. And I say, if I turn them off, There's nothing shown in QGIS because the actual stuff from Data Explorer doesn't have an actual geometry in it. Although we can look at its contents, but there's nothing for QGIS to actual map. So in the next section, we'll link the stats to the boundaries, and then QGIS will display that census data as a map. But that's moving ahead. I've got some slides first, so I'm going to go back to my slides. Hopefully that's caught folk up. So let me just stick the slideshow back on. So yeah, had a wee break. So what we're concerned with census mapping is creating choropleth maps. So a choropleth map is a lot of it is a sort of typical map you'll see with census data. And it's sort of census boundaries, sort of boundaries shaded a different color depending on the actual census variable being shown. So on the left, you have like the raw data. So this is showing part of Scotland. It's in Edinburgh. So I think these are council areas. So you've got like 9-digit codes and then like a colon. And then after it, there's some value like 15.55, 8.2, 8.47. These are just some proportional census uh, variable. It's not very. So what we do, we could just shade the polygons depending on the actual underlying value. And that's what a choropleth map is showing. It's an easy way to show or visualize how a census variable varies across space. And that space could be the entire country of the UK. So this could be some census variable. I think this is showing like people employed in forestry or something. So as you might expect, most people who work in forestry tend to be in rural areas like the Scottish borders or rural Wales, or I think this must be around the Lake District, and less so in the City of London. Whereas I think this is a choropleth map showing, this is actually Nottingham. I don't know what the actual census variable is, but it's presumably something like a house type, like number of people living in detached houses or something. And so by mapping the data as a choropleth map, it allows you to understand the variance in the census data. There's a gotcha with the choropleth map though, because it implies that the underlying population is distributed distributed evenly across the extent of the polygon. If you look at reality, so what we have here is this is an aerial photograph from the Ordnance Survey, and overlaying on these black outlines are the actual output area polygons. And obviously across this is a single polygon, which polygon's not shown, but you can see the underlying aerial photography. And where the actual people actually live is here, but not here. So there's all this area of space here, which is occupied by parkland or industry or something. So if we were to shade this like a single all one color, it sort of gives a false representation of the actual underlying where the population are actually located. So at the end of the presentation, we'll see some of the efforts the ONS and people at UCL and Liverpool have used to try and create alternative maps to choropleths, which gives a much more better representation of the actual underlying population. So, but I say, as long as we're aware of this limitation, the choropleth map is still quite a good way of like getting of mapping census data, just to explore the variation in the census variables, and to communicate sort of the differences in how the census data is within the data set. And so this is the sort of map I'm going to create and choose for the rest of this day. So it's actually a PDF I'm going to create in QGIS. And I say I'm showing the percentage of people in Leeds who live in flats as recorded by the 2021 census. So you should recognize some of this data. We've got that OS backdrop map, and we've got some boundaries for the electoral wards, and I've shaded them according to the percentage of households that live in flats. And the components of this there's like obviously a map census variable, which in our case is the population, the proportion of households within each ward that live in a flat. There's those census boundary geography, the census geography boundaries, the electoral ward boundaries that we download from Boundary Data Selector. And we're going to have to link those census variables to the boundaries. I've done a thing called a choropleth map classification. So I've told QGIS how to shade each polygon based on the underlying pop census variable. I've specified a specific type of color ramp. So the color ramp is say in this case, it's from white to dark blue, and it's told QGIS is saying that the lowest value display white, and the maximum value display dark blue, and then between display different shades of blue. But I could have used green or red or something. But there are different types of color map, which we'll look at. And an important thing is to provide a data attribution statement. Although all of the census data we provide for the UK data source is open data, there are conditions of use attached to using that data to reference who the data came from. And so that's, especially if you're creating a map, it's important to include a data attribution statement to say that data came from the Office of National Statistics. And because we're showing boundaries, those boundaries have residual IPR with the Ordnance Survey. So that's another important component of the map. And you'll notice on my slides, whenever I show a boundary, I've got an additional copyright statement. And that's to basically comply with the usage of that data. So in this is quite a short bit. All I'm going to do is relate that census attribute stats to the boundaries. And we do that using a data join in QGIS. So we've got the census boundaries that don't have any stats. We've got those stats themselves. But common to each of the data sets is the geographic identifier, which is this 9-digit code that uniquely references each of the different wards. And so that ward, as long as that code is present in the boundaries and the stats, we can join them to one another, and then the boundaries will then take on the census variable stats. And then this is going to be a very quick demo, but essentially we're just going to do that table join. So, and again, so at the QGIS. So I'll just stick the boundaries back on and the west backdrop map. So I say, again, I open the attribute table. There's no census stats currently in it. But the key thing is this wards code identifier. So each of these 9-digit codes uniquely identifies a ward. And if I open the actual stats, which is our imported data, again, you can see we've got the identifier here. And the idea is that QGIS will use that code to map, to link the stats to the boundaries. And again, the way that we set up we do this join is using this properties menu. So again, you select the layer in QGIS, right click, properties. And there's different, down the left here are all the different sort of properties and actions we can perform on that boundary data set. So information just tells us where that data set is stored. So at the minute it's got my downloads folder. It tells me it's in the British National Grid coordinate system. It gives me some extent. It tells me sort of fields. This is all metadata about the data. We could filter the data at this point, so we could tell QGIS to only display certain polygons within the data set. Later, we'll use this symbology thing to create the crawlpath map to tell QGIS how to display the boundaries. But for now, I'm going to do a table join, and this is going to join the stats from the census CSV to the boundaries. So joins, got buttons here, so I'm going to add a new join. And the join layer is that set of census statistics that we downloaded from Data Explorer and I manipulated in LibreOffice Calc. So it's pre-selected it because there's only one actual CSV file in my QGIS project. And it's also pre-selected the first field, that's that geographic identifier, the ward. And the target field is that ward identifier in my actual shapefile. So at the minute it's FID, which is not what we want. We want ward code. Although they're different names, the actual values of these columns are those 9-digit geographic identifiers. And I say QGIS will match the records with the same value in the stats and the boundaries. So that's okay. And just hit OK. And you can see it's added a join. And just apply that and OK. And this time when I open the attribute table of the boundaries, you can see it's appended all the stats from the census data. And this should be familiar. So we've got like our raw counts, our proportional values, and then our categories that summary category thing that I added to show that across the 8 types of property, which is the dominant type for that electoral ward. And again, I can use this identify button to click on one of the polygons, and QGIS will show me those values for that polygon. Because I've got a raster data here, it's asking me if I want to identify either the boundaries or the polygon. So I just, yeah, that's okay. So back to the slides. And when we're creating choropleth maps, there are some issues we have to consider. So we have to consider the choice of census output geography, the choice of the choropleth map classification method, and the choice of the choropleth color ramp. So in terms of the output geography, as I said, the census data is available at different types of different levels of output geography. In this case, we've got 3 maps down the side. So census output areas, what are known as the lower layer super output areas, and middle layer super output areas. And so the output areas are the smallest ones, which could be like a couple of hundred people. An LSUA maybe a couple of thousand people, and MSO will be tens of thousands of people. And so you can get the census data depending on the disclosure control at different levels of geography. So, and I say if you map the data or analyze at different levels, you can get the general pattern should be the same, but at the output area level you might get more noise. Whereas at the larger areas, that will be the noise will tend to be removed, and you get more of a smoothing of the data. And so it's just an interesting thing. And I say because of the disclosure control, you may find that the census variable you want is not available at all levels of geography. So, so it's just to make sure you be aware of the different levels of geography that your data is available for, and just to explore the data at different spatial scales to understand the sort of patterns in that data. And in terms of choropleth mapping, that's mapping the data by different types of boundary or geography. So these are 3 choropleth maps showing the data at output area level, LSUA level, and MSUA level. When we actually create a choropleth map, we're doing a classification of the data. So within a numerical data set, such as census attribute data, there's a range of values from low to high. And when we create a data classification, what we're doing is we're simplifying that data into what are known as data buckets. And that allows us to see patterns in the data. And so you can see here, so on the right here, I've got a table of values going from 3 to 93. So that's the range of values in that data set. And what I can do is I can create different data buckets and place the different values in those buckets according to a minimum and maximum value. There's different types of data classification methods. I'm using what's called an equal interval one here. So I've simplified the data into 5 data classes from 3 to 20, values from 3 to 20, 21 to 38, 39 to 56, 57 to 74, and 75 plus. So there's 5 data classes, each of which span a range of 17 values. And that just allows us to simplify the data. And that's what a choropleth map classification does. It just takes that the range of the data and arranges the data into different types of buckets. and there are different types, there are different algorithms that will, and the different algorithms basically um, define the buckets in different ways. An equal interval one is fine, but it's quite simple. And if the actual range of the data was low, if there's more of the data in the lower or upper range, then just using these the similar classes may mean that in the upper or lower range we can't actually see the differences. So it might be better to have more buckets at the lower or upper range of the data to get a more fully understanding of the data. And we'll see that in QGIS later on because we can flick between the different types of classification and you can see how that changes the map that gets shown. And I say there are different types of chlorophyll map classification methods. So that was an equal interval one, and there's a whole range. I'm not going to go into details of each one, but I mean, it's just a case of looking at your data, understanding your underlying data, and then trying out the different classification methods. And the point is, if you have the same data set, depending on which classification method you pick, you can create a different type of chlorophyll map. Another thing, you can also get a different map by depending on the number of those buckets you pick, as you can see here on the right. So this is the same underlying data using the same boundaries and the same classification method, but I've varied the number of those buckets between 3, 5, and 7, and you get a different map depending on which one you pick. So, and again, on the left here the classes are the same. So we've got 5 classes, but I've varied the actual classification method. And again, you get a different kind of map. So you could, depending what so just to be aware that the different classification method and number of buckets will produce different maps. And so it's best that you understand the data to avoid creating misleading maps. And this, and then when we shade the data in the chlorophyll map, we pick a color ramp. And there are different types of color ramp. So we have sequential color ramps, which go from low to high values. So this is green. So this is going from like light green to dark green. So we get low values of light green, high values dark green. Diverging is like decreasing or increasing around a central value, which is here. So the central value could be white, it could be 0. To the extreme left could be like -10, and then between 0 and -10. To the right be +10, so 0 to +10. And then qualitative it's a lot simpler. It's not so much a data classification. We might have a land use map which shows polygons of agricultural areas or water or roads, and simply we just shade those a different color depending on the type of land use, and that's what a qualitative color amp is doing. And so you might have like red for roads, green for land use, blue for water, and it's just a simple. If the land use is blue, sorry, if the land use is water, show blue. Yeah. And we'll see this in our QGIS later on because we'll use a qualitative color ramp to shade that categorical value of the dominant accommodation type. And so the fun stuff now is to create categorical and chlorophyll maps in QGIS using our linked data. So, and I'm going to take a categorical map based on that and dominant accommodation type, and then a univariate chlorophyll map from our percentage of flats. So jump back to QGIS. Just get rid of this. I'm just going to clear my selection. So again, with QGIS, right-click properties. And in the same way, joined was a property, we can click on symbology. And at the minute, QGIS is just displaying all the polygons with the same color. So I can change this to like pink and click apply. And you can see it's reshaded. But I want to do an actual data classification. And the first one I do is that simple categorical map of our dominant accommodation type. So instead of single symbol, I want categorized. And the value is the column in our census data that we want to map. They want to tell QGIS to shade according to the different value. So here's my columns in that census data. And it's this dominant AC type, which is the one we created. And I can just get classify. And you can see what it's looked at. It's looked at each of our values, so detached, flat, semi-detached, terrace, and it's assigned a unique color to that value. I'm just going to make this. The legend is like in a map, you have a map legend which tells you what the colors or the symbols the map actually mean. And it is very important so the reader of your map knows what data is being shown. And by default, QGIS has used the actual value. I'm going to make this clearer. So this is detached houses. Flats. Terraced houses. And I'm going to, QGIS by default always creates a thing called all our values, which is for any values which are not in the actual classes. In our case, we know that all our records have one of four values because we create an expression in Excel that defined that. So I can get rid of this by just clicking on the class and hitting this delete button. And I'm also going to reorder the way the items are shown in the legend. So they're sort of a more, to my mind, aesthetically pleasing order. So I'm going to start with detached houses and go to semi-detached houses. And then it's a more logical order going from homes to flat, going from detached homes to semi-detached houses to terraces to flats. And again, we can also, at the individual classes, we can change the colors that are shown in. So rather than brown here, we shall use dark green for detached houses. For semi-detached, we will use, say, a lighter shade of green. For terraces, some sort of purple, I guess. Or maybe a red. I don't know. The red brick northern cities. And for flat, purple's probably okay. And now if I apply that, and now QGIS to shade those polygons according to that underlying categorical value. So in the case of Leeds, the dominant accommodation type in the city centre is flats. It then moves to terrace houses in the suburbs of suburban Leeds and to the semi-detached houses in the further out. And you only really get dominant accommodation of detached houses in the countryside of rural Yorkshire. And because we, at the minute, we can make things clearer by changing the transparency of the polygons. So we can see more of the background Ordnance Survey mapping. So at the minute, the opacity is 100%. So the actual underlying map is not showing through the polygons. But I can change this to a smaller value of like 80%. And now we can see the actual underlying Ordnance Survey background mapping coming through the polygons. So it's a lot easier to locate ourselves within our map. So again, you can see the flats are within Leeds city centre, the dominant of the terrace houses within, and then semi-detached, and then the rural is only, or the small villages is where you're only actually getting the detached houses as the dominant accommodation type. So that's a categorical mapping. And I want to do an actual univariate choropleth mapping. So I want to actually, instead of QGIS shading a polygon according to a unique value, it's going to shade the polygon according to a data bucket based on a classification we apply to the data. So again, right-click the layer, properties, symbology. Instead of categorize, we want graduated. And again, the value, we pick the type of the column we want to map. So we don't use our raw population values of caravan. We want to use that proportional value we used. So I want to do flat proportion, and that's the proportion of flats within each ward as a proportion of the total number of households. And I can just do and we set here the choropleth classification. You can see here it's created 5 classes with an upper and maximum value for each class. So got here upper minimum to maximum, minimum to maximum. And if you click on the histogram here and click on load values, QGIS will show you like the frequency of those data values across the range. So again, here in our case, our data is like the histogram is skewed towards lower values below 30. So, and there's less data at like the higher range. So you might decide that the equal interval is not particularly good here, and we'll choose a natural breaks classification instead, which is slightly better. And I can also increase the number of classes here. So at the minute it's showing them 5. I can put that to 7. And again, QGIS will reclassify the gate data according to those data buckets. At the minute it's showing them by red, so low values in white to light red, high values in dark red. And I'm going to change that to blues. So that's my color ramp. Hit apply. And again, QGIS has shaded the data. And so that's great. And so my data is in QGIS. It's a choropleth map. What I want to create now is an actual output document, a map document as a PDF that I could incorporate into my reports or my dissertation or whatever using the census data. And that's done using a thing in QGIS called a print layout. So you go to project, new print layout, and you have to give the print layout a new title. So I'm going to call this my census map. And what it does, you get like a separate window. And this is like if you're using like Word or Excel or sort of PowerPoint, you drag different components onto this canvas to just define how the print layout will be created. At the minute it's showing landscape mode. I'm going to change this to portrait mode. So again, all of the steps I'm showing here are in that PDF workbook. So if you miss what I'm showing here, you can refer back to that and walk through them yourself. So let me just change the properties from, page properties from landscape to portrait. So we've now got our portrait canvas. Down here are the different sort of elements of the map PDF layout we want to add. So I'm going to add like again, it will show the tooltip if you just let the mouse hover over them. So I'm going to add map. So QGIS has added new. Let me just zoom in a bit. Okay. So there's our map. And I say an important part of a map is a legend, so that the reader of our map can tell what the map is actually showing. Because by default, sorry, if I just provided this, the reader has no understanding of what this is actually showing. It's showing, they can tell it's for leads and it's got some shaded polygons. They don't actually know what these shaded polygons mean. So we have to add an actual map legend. So again, we just add the legend from the set of controls in the toolbox. Um, at the minute, oops, it's created a legend item for that underlying Ordnance Survey map, which I don't want, because if you look in the actual, it's if you look in the actual layout, it's enormous because it's basically created a class for every unique value in that raster map, which looks really bad. So I'm going to get rid of that. So that removes that, and that's a lot better. I'm now just going to tweak the content of the legend. So just make this full screen. The layout thing is quite hard to use, but or it is worth referring to your workbook when you're using it because it's got quite a lot of small submenus and stuff. But with practice, it's okay. So what I'm going to do here is just make the classes a bit more obvious what they're showing. So in our case, it's percentage flats. And you can see it's updating what's shown in the actual print layout as I edit things in this widget. Oops. And I'm just going to change the name of this to so we've got legend here. And we can resize it. Um, and then because it's a map, some important things to add are not necessarily in our case, but I always like to have them, is a scale bar, which just tells us on the map how big things actually are. So um, we're not using this map for navigation purposes, so it's less important, but it's still good to give us like some indication of how big these actual electoral wards are in the real world. And a north arrow, which again is even less useful because we're not using navigation, but it's just useful to orientate ourselves. So these are again just widgets I add to the map. And then we could add a title to the map. So, and this is using this text control here. So add a label. Um, so my uh, Okay. And I say an important thing to add is a copyright statement to our map. So when you download the census boundaries, if I go back to the data, which is boundary data, there's a terms and conditions.html document. So let me just open that up now. And this has basically the terms and conditions of that boundary data set. Then it's got some boilerplate code here, so some boilerplate attribution statement we can use in QGIS. So that's this one here. So you can see the data is coming from National Statistics, and it contains Ordnance Survey data, Crown copyright and date rights year. Yep. So I'm just going to grab straight that data, that text, and use that into my layout. So I'm going to add another text box here and just paste in that attribution statement. And the thing to correct here is like there's a year as a placeholder. We want to change that to this actual year today. So 2026. And I did the same thing in all my slides. So we have our map. And then to get it as a PDF, you can use this button here. So, and it's like an Acrobat logo. So exports PDF. My census map's probably okay. My census map for Leeds. And just save that. And while you open my PDF, you have our nice census map for Leeds. I mean, you could spend more time than I spent here making it a lot nicer. You could add like an outline box around here, or you could have a logo of your university or your company, and extra text and other information. So that's great. So we have data we've created a univariate chlorophyll map in QGIS from our census data. So back to the slides. There are other types of census map, which we're going to look at now. So there's a thing called bivariate chlorophyll maps. There are cartograms, and there are dasometric and mass chlorophyll maps. So bivariate chlorophyll maps. So most chlorophyll maps, and the ones we create today, are called univariate chlorophyll maps because they're only displaying a single census variable. A bivariate chlorophyll map, on the other hand, can show on the same map two variables. In some way, this provides some means to display multivariate data, which can be quite nice to explore to show the relationship between different census variables. And so that you can see that's what's happening right here. So I've got two census variables, poor health and unemployment. And they basically get combined to create a bivariate chlorophyll map. So in the poor health, all the values are from shades of pink. So grey, light to dark. Unemployment goes from light, cyan, light, darker, very dark. And if I map that as a chlorophyll map, then you end up with your legend that instead of being shown as a linear 3, it gets displayed as a matrix. So 3 by 3 values, and it combines the colors when they get overlain. So combination of dark pink and dark cyan will produce very dark blue. Combinations of light grey and light grey just produces grey. And a combination of a middle pink and middle cyan produces this sort of lighter blue. And so you end up with this legend with 9 values arranged in a grid. And on the corresponding map, instead of shades of pink and cyan, you end up with like pink, cyan, blue, and grey. And so on the map here, the areas of darkest blue are where both unemployment and poor health is high, and where grey is where areas of unemployment and poor health are low. And it's quite a nice way of just displaying two census variables at the same time. although you have to be careful to make sure that those variables have some sort of relationship to one another, because otherwise you could create quite spurious maps. And I'm just going to talk about cartograms first, but at the end of the session, I'm going to show you how you can create a bivariate choropleth map in QGIS. And so a cartogram is like a different sort of geographic visualization altogether. Instead of a choropleth map, where we retain the shape of the census boundaries and simply shade the polygon a different color based on the census variable, in a cartogram, we actually we change the actual shape and size of the census boundary based on that underlying census variable. We distort them. So a small polygon that has a high value attached to it could become a lot larger, whereas a large census area, which has a low census value attached to it, could shrink. And that's useful because if you have a case like this on the right-hand side here, which is showing data on counter area for all of Scotland, I think it's showing that it's actually showing a change of people living in a property mortgaged by the Octopus between 2001 and 2011. It's quite hard to tell here in the central belt Scotland. So that's like the Glasgow council area, Edinburgh council area, and Middle Lothian and stuff, because the polygons are so small. Whereas if we distort the shape of them by constructing a cartogram, it's a lot more obvious. The council areas stand out a lot more better, as can show on the cartogram. And there are different types of cartogram. There's a non-contiguous cartogram, contiguous cartogram, and what are called Dorling cartograms, named after Danny Dorling, who is a professor of geography and generated these early on. I say cartograms are a different way of visualizing census data. Again, at the end, I'm going to show how you can create a cartogram using QGIS. Cartograms feature quite prominently in the wild, as I say. I don't know if people can remember the Brexit referendum of 2016, which seems a long time ago now, but cartograms featured prominently in the reporting by The Guardian to create things like this. The benefit of this being that, again, Scotland, few people, big areas, southeast of England, lots of people, smaller areas. So if you display data by cartogram, it can, in some ways, produce a clearer map or visualization. And again, there's this great book that was produced for the 2011 census called People and Places, again, co-written by Danny Dorling, which used area-based cartograms to present census data for 2011. And so I'm now going to show you how you can create a bivariate choropleth map and an area cartogram in QGIS. Oops. So back to QGIS. And I'm going to use a different data set for this because it's got slim, so I'm going to use more variables. So I'm going to turn this off. And again, I'm going to go back, keep the base map on. Oops, a bit too far there. So back to the data source manager. And this time I'm going to use a data set known as a geo package. So this is not a shapefile, but it's another type of geospatial data. So geo package. And I've got this data created earlier. So, and this data is actually in that GitHub repo we gave you. So if you download that or data pack, you'll be able to use this data. So this is a similar folder structure you have in that data pack. So it's this data for bivariate and cartogram. And it's a geo package. You can see it's a geo package database. So in QGIS, you first have to pick the geo package. So QGIS is aware of it, and then you have to connect to it because underneath it is like a small geospatial database. And it can, unlike a shapefile, a single geo package can contain multiple layers of data. So that's what I've done here. I've made QGIS aware of the data set, and I now connect to it. There's currently only just one data set in it, which is a Leeds data set, and it includes it's the electoral wards, and as well as that accommodation type, it also has information on tenure. So again, do people rent? Are they mortgaged? Are they getting housing for a housing association or whatever? So let me just add that to QGIS. And again, you'll recognize some familiar polygons. Again, QGIS is by default showing them one color. If I open the attribute table, you can see our different columns of data. So again, we've got the ward name, the ward code. AT means accommodation type, so accommodation type detached, accommodation type terrace, 10 rent-free. The 10 bit means tenure types, rent-free, mortgage, social renting, whatever. And so in QGIS, I want to create both a bivariate choropleth map and a cartogram. Because I said QGIS is an open source piece of software, that means that it has this great feature called a plugin, where developers or users in the QGIS community can add extra tools and applications to the main QGIS dataset application to extend its range of functionality. And so in our case, someone's written a plugin for QGIS that allows one to create a bivariate choropleth maps and also cartograms. And to access plugins to QGIS to add more functionality, we use this plugins menu. And so I go to Manage and Install Plugins. It will first, again, the common theme in QGIS that most of the menus tend to have things down the left, which I'll allow you to access different parts and add different things. So at the minute, QGIS is showing all the plugins that are available within the QGIS community to add to QGIS. Installed will show me which plugins I've currently installed on my local instance of QGIS. Again, not installed is a subset of all the QGIS things that are available, and upgradable to say, so it's saying this one can be upgraded. And if I go to installed, I can see that I've installed this bivariate color polygon renderer. So you can see the grid again. So this is going to allow me in QGIS to create a bivariate choropleth map. And cartogram 3 is going to allow me to create a cartogram in QGIS. And you can see this had a lot of work on it because it's got this change log. So, and you can see this just tells you about the plugin, who created it. There's probably a link to a GitHub somewhere for the underlying source code. But that's okay. I've got these two ones installed, so I can close the plugin installer. If you can see this button here, this is the cartogram. This is a new button that allows me to access the cartogram functionality in the plugin. Again, go to properties. So again, I'm just going to change the type of symbology to display this layer. So we've seen single symbol. We saw categorize, which was our category map of the dominant accommodation type. We saw graduated, which was our univariate choropleth map. And I'm going to use bivariate renderer. So this is a new option that bivariate choropleth plugin has added to the QGIS widget. So it seamlessly added a new option to our symbolizer here. In this case, instead of just picking a single column to map, we have to pick two. So the different axes of our bivariate choropleth map. So I'm going to go accommodation type flat and accommodation type private rented. And this is going to create a bivariate choropleth map showing the proportion of households living in flats that are also private rented. And for each axis, I think it just applies like an equal interval of low, medium, and high on them. So you get less control of the actual classification method used, just so it creates like three classes in each axis. But we can change the color ramps. But I'm going to stick with the two we have here. So a range of cyan and pink. And I'll maybe just change the opacity again. hit apply, and see QGIS has gone away and created our bivariate chlorophyll map. And it's created a legend item for us as well. So I can just zoom in and see then leads. So the dark blue is electoral wards where the households living in both flat and private rent is high. The grey is where they're low, and then all the other values are intermediate values between those. And again, we could just create like a print layout. Great. And we could add our bivariate chlorophyll to QGIS and include our legend again. And this time it is added that special type of bivariate legend. And then I now want to create a cartogram from the same data. Let me just, for now, I'm just gonna create a univariate first. And using our cartogram, so that we're going to create a cartogram for the electoral ward for Leeds based on the proportion of households living in flats. And what the cartogram is going to do is change the shape and size of the electoral ward boundaries according to that underlying population value, rather than just shading them the same color. So we click on the cartogram button. The widget is quite simple. It's literally, you specify the input layer. So I'm going to change that to it references my geo package. And then you tell it which column to use to start the polygons. So flat. I'm going to leave these at defaults and just hit the OK button. And it will take a few seconds for QGIS to actually create the data because it's having to look at all the geometries and distort them. So it's relatively computationally expensive. And when I hit this OK button, you'll see a progress bar here as it computes the cartogram, as you can see here. So QGIS is doing some work in the background. And it's looking at all those polygons and distorting them according to the underlying value. And so there we go. Here's our cartogram. Maybe I've made this. So as you say, it's distorted our electoral ward boundaries. So in the city centre, where there are more folk living in flats, the polygons have got larger. And whereas on the suburbs, where there's less people living flat, they've shrunk. But the good thing about this type of cartogram is it maintains what they call the topological relationship between the different polygons. So that if the two polygons were neighbors in the original data set, that's maintained in the cartogram. It's reshaped them so that gets maintained because that could be important in how you understand the data. So we've created categorical maps, univariate chlorophyll maps, bivariate chlorophyll maps, and cartograms in QGIS. So I don't have any more demos in QGIS. I'm just going to go back to the slides and show you a final type of visualization. So the final type of visualization you can get map is called a dasometric map. And so this is to address this problem where you have of chlorophyll maps, where you discover that the underlying population is not uniformly distributed across the extent of the polygon. And what a dasometric map does, it modifies the chlorophyll map by using additional data sets to display a more realistic distribution of that distribution. And so a simpler way of doing that is just to take a buildings layer and just to shade, rather than shading the entire polygon, just shade the parts of the electoral ward that are actual in a building. And so that creates like a building mask, and that helps to just give a more realistic depiction of the data. So rather than what's actually used in a glorified map. And it can be done in QGIS, but it's quite an involved process and involves quite a lot of what they call geoprocessing, because you have to have a small, you have to have like overlay the ward bound, the census wards, etc., on top of the buildings, and then do what they call a spatial intersection. But luckily for us, people such as the Ordnance Survey, University College London, and Liverpool have done this already, and there are two great online mapping tools that you can do this. You can see this data yourself. So, Data Shine was originally created by University College London for the 2011 data. And so they have this thing called Data Shine Census, which allows you to display the census data using this data metric style mapping of shading the buildings. And the ONS have since adapted this methodology in their census map website, which produces maps of 2021 census data, again using this like data metric style building shading, and you can see that on the ONS website. In Scotland, they've done the same thing, so you can get Census Map Scotland, which uses the same sort of methodology in Scotland. So this is really coming towards the end of the webinar. To help you further with census data, there is a UK Data Service training program, of which this webinar is one of them. This webinar will be repeated in July, so I'll be going through the same QGIS demos and slides again, possibly slightly tweaked. We are, within the UK Data Service Census Support, we are developing a set of UKDS training modules, which will provide more information on QGIS. We're also trying to develop some modules that will provide stuff on doing stuff using Python or R. So how you link data using Python or R, how you create maps in Python or R, and really modules that go more behind the scenes of the actual how the census data is created. So how do we create census area boundaries, and then how do we deal with problems like changing geographies over time? So how do you compare data in 2021 with 2011 or 2001? Because those are quite tricky questions to deal with. So the idea is that over the next 6 to 12 months, we're going to develop these modules and then make them available on the UK Data Service website. For more direct help, there's the UK Data Service Help Desk, where you can raise a question. If it's a census question, that will get routed to the most useful person to answer that question within the census team, which could be me here in Edinburgh if it's about mapping and doing change over time or comparing geographies. If it's the actual stats themselves, that will be routed to guys in GISC. If it's stuff about the flow data, that will go to guys in UCL who look after WICID. We also have a census data drop-in session, which is the first one that will be a week today at 1 o'clock. You can come along to that drop-in session, have any questions you might want to ask about what you saw today or any other questions about census data. So if that's of interest to you, then sign up and you can join me and my colleague Placide and others to get more information about the census data. So I just want to thank you for your time and see if there's any questions that people have asked during the session.